We used to think that black holes were stationary, but we were shocked. Shocked to find that there are rogue black holes that wander across the galaxy.
What if there was a place in the universe so powerful, so utterly terrifying, that it could pull anything into its grasp and never let go? Black holes. Just hearing the name stirs up a sense of dread. They hint at an infinite void where time stands still, and the very laws of physics seem to unravel. But what really happens if you fall into one? And what occurs when two of these cosmic giants collide? Here are some jaw-dropping facts about black holes that will push the boundaries of your imagination. The birth of black holes. First up, how are black holes born? These cosmic titans are forged from the remnants of massive stars that have reached the end of their lives. When a star's core is more than 3 times the mass of our sun, gravity takes over, crushing everything down until a black hole is born. Black holes are incredibly dense objects with such immense gravitational pull that not even light can escape. Astronomers think that most spiral and elliptical galaxies, including our own Milky Way, harbor these dark giants at their centers. Now let's talk about the types. The smallest, called stellar mass black holes, are between 1 and 100 times the mass of the sun. They form when the core of a massive star collapses, sparking a supernova, a stellar explosion of epic proportions. Then there are the supermassive black holes, true behemoths with masses millions or even billions of times that of the sun. It's believed these giants grow by merging with other black holes and devouring stars. But there's also a third kind. Intermediate mass black holes. These elusive objects, still somewhat of a cosmic mystery, fall between stellar mass and supermassive black holes in size, with masses ranging from 100 to 100,000 suns. Only a few of these have been discovered, but they hint at even more wonders lurking in the depths of space. What would happen if you fell into one? So the big question, what would actually happen if you took a plunge into a black hole? Well, the outcome isn't exactly a happy ending, no matter which type of black hole you choose. If you were to take a dive into a stellar mass black hole, you'd face a process known as spaghettification. Yes, that's the real term. The black hole's immense gravity would stretch you from head to toe, pulling you apart like a strand of spaghetti. Now, if you were to opt for a supermassive black hole, the experience might be slightly less gruesome. Take Sagittarius A, for instance, the supermassive black hole at the center of our Milky Way. It's a colossal beast around 44 million kilometers across and contains about 4.31 million times the mass of the sun. Discovered in 1974 by astronomers Bruce Ballack and Robert L. Brown, it wasn't given its name until 1982. Your journey into Sagittarius A begins the moment you cross the event horizon, the infamous point of no return. Once inside, you could see out, but no one on the outside would see you, because any light trying to escape would fall right back in. The good news? Despite the black hole's monstrous gravitational pull, it wouldn't stretch you into a spaghetti-like form as a smaller black hole would. But here's the catch. You wouldn't be able to escape. Or could you? There's a glimmer of hope in the theory of white holes. If black holes suck everything in, then white holes are thought to spit things out, possibly in some far-off corner of the universe. The two might be connected by an interdimensional tunnel known as a wormhole. Another possibility? If you waited long enough, billions of years to be exact, the black hole could transform into a white one. But don't worry, due to the intense gravitational forces, time would speed up for you, and it would feel like mere milliseconds. Of course, this is all just theoretical for now. Need more evidence that diving into a black hole isn't the best idea? Take the tidal disruption event observed by NASA telescopes in 2014. A star got too close to a black hole, about 290 million light-years away, and was stretched, distorted, and shredded before being sucked into the singularity. The remains of the star were then flung out in what can only be described as a cosmic belch. As for Earth, the closest known black hole is Gaia B81, located about 1/1600 light-years away. So, no need to worry, we're safe from being sucked in, at least for now. Can we see them? Can we actually see black holes? Not directly. These cosmic giants have such intense gravity that even light can't escape, making them invisible to traditional telescopes. Instead, astronomers rely on massive radio telescopes and gravitational wave detectors to track these elusive objects. Back in 1915, Albert Einstein theorized that objects moving through space create ripples in space-time, much like how a stone creates waves on a pond's surface. Fast forward a century, and in 2015, his theory was proven right when researchers at the Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves for the first time. These waves were the result of two black holes colliding 1.3 billion years ago. But how do we locate black holes if we can't see them? We can detect them by observing the impact they have on their surroundings. As black holes consume gas, dust, and stars, this material becomes superheated and emits radiation, which can be captured as a heat image. In April 2019, the Event Horizon Telescope, a network of 8 ground-based radio telescopes, achieved a historic milestone by capturing the first ever image of a black hole and its shadow in the galaxy Messier 87, part of the Virgo galaxy cluster. This image revealed a glowing ring around a black hole 6.5 billion times more massive than the Sun, located 55 million light-years from Earth. That bright halo? It's the heat given off by gas swirling around the event horizon, the very brink of the black hole, before it's swallowed whole. How many black holes lurk in the Milky Way? According to the Space Telescope Science Institute, only about 1 in every 1,000 stars is massive enough to become a black hole. With over 100 billion stars in the Milky Way, our galaxy likely hides around 100 million black holes. Detecting them is no easy feat, though. NASA estimates that the Milky Way could be home to anywhere from 10 million to a billion stellar black holes. Black holes do not suck. Now let's clear up a common myth. Black holes don't actually suck things in like a cosmic vacuum. Instead, they behave like any other object in space, just with an extremely powerful gravitational field. If the Sun were suddenly replaced by a black hole of the same mass, Earth would keep orbiting it as usual. No dramatic pull into oblivion. So why does it look like black holes are devouring everything around them? It's because companion stars often lose some of their mass through stellar wind, and that material gets caught in the black hole's gravitational grip, giving the appearance that the black hole is consuming everything nearby. The mystery of black hole, hair. Back in the 1960s, physicist John Wheeler coined the phrase that black holes have no hair, suggesting that these cosmic giants could only be identified by their spin, mass, and angular momentum. Everything else, the so-called hair, was believed to vanish beyond the event horizon, a boundary where not even light can escape. Fast forward to 2016, and the legendary Stephen Hawking shook things up with a new theory. He proposed that black holes might actually sport a kind of cosmic hair made up of ghostly, zero-energy particles. According to this idea, this mysterious hair could hold clues about the material a black hole has devoured. While this theory is still under exploration and has yet to be proven, it could provide answers to the long-standing mystery of what really happens to the gas and dust that fall into a black hole's grasp. What if the Sun turned into a black hole? The Sun will never turn into a black hole. It simply doesn't have the mass needed to go out with that kind of bang. Instead, it will end its life as a dense stellar remnant known as a white dwarf. But let's entertain a hypothetical scenario. If the Sun suddenly transformed into a black hole while keeping its current mass, the orbits of the planets, including Earth, would remain unchanged. The gravitational pull would be the same, so Earth would continue its usual path around the Sun. The catch? Without sunlight, life on Earth would face a grim fate, as the planet would be plunged into darkness and extreme cold, making survival impossible. Have black holes had any influence on our planet? Stellar mass black holes are born from the violent deaths of massive stars. When these stars explode, they scatter essential elements like carbon, nitrogen, and oxygen into space, the very building blocks of life. But these explosions do more than just seed the universe. They also create shock waves that can spark the birth of new stars and solar systems. In a way, our existence on Earth traces back to these ancient cosmic events, where explosions and collisions left behind black holes, and spread the ingredients necessary for life across the cosmos. On a grander scale, supermassive black holes seem to lie at the heart of most galaxies. But the mystery deepens when we try to unravel how these colossal black holes and their galaxies are connected. Did a black hole help shape our Milky Way? Or did the galaxy give birth to the black hole? This cosmic chicken and egg dilemma remains one of the universe's greatest unsolved mysteries. Do black holes shrink over time? Yes, black holes can get smaller. The late physicist Stephen Hawking unveiled a groundbreaking concept. While black holes grow by absorbing matter, they also gradually shrink through a process known as Hawking radiation. Here's how it works. Space isn't truly empty. It's teeming with particles that flicker in and out of existence. When a pair of these particles forms near a black hole, one may get swallowed by the black hole before it can vanish. Meanwhile, its partner escapes into space. This process siphons off energy from the black hole, causing it to lose mass over time. In theory, black holes will eventually evaporate entirely through this process of Hawking radiation. However, don't expect this to happen anytime soon. For most black holes, even those a few times the mass of the Sun, this evaporation would take far longer than the current age of the universe. So these cosmic giants will be around for an incredibly long time yet. Wormholes versus black holes. Cosmic shortcuts or cosmic traps. A wormhole, also known as a Lorentzian wormhole, is a hypothetical tunnel through the fabric of space-time. It's the stuff of sci-fi dreams, frequently depicted as the gateway for interstellar travel in movies like Star Trek. Imagine it as a cosmic shortcut, a direct route from one corner of the universe to another, bypassing the vast distances in between. In contrast, a black hole might seem more like a cosmic blender, pulling everything in with its intense gravity. Yet some physicists argue that black holes and wormholes might not be as different as they appear. There's a tantalizing theory that suggests these enigmatic phenomena could be two sides of the same cosmic coin. Could a wormhole be a type of black hole, or vice versa? The boundaries between these cosmic mysteries are more blurred than you might think. Powerhouses of the cosmos. Black holes are cosmic powerhouses, generating energy far more efficiently than our sun. The secret lies in the disk of material swirling around them. Material closest to the event horizon, the boundary around a black hole, orbits at blistering speeds compared to material further out. This is because the gravitational pull near the event horizon is immensely stronger. As this material speeds up, it heats up to billions of degrees Fahrenheit. This extreme heat causes it to emit energy in the form of blackbody radiation, transforming a significant portion of its mass into energy. While nuclear fusion in stars like our Sun converts about 0.7% of mass into energy, the intense conditions near a black hole boost this conversion rate to an impressive 10%. That's a staggering difference, showcasing just how much power these cosmic giants wield. Could black holes create new universes? It might seem outlandish to think that black holes could give birth to new universes, especially when we're still debating whether other universes even exist. But this idea is at the cutting edge of scientific research right now. Here's a simplified take on it. Our universe is perfectly tuned to support life, with conditions that just so happened to align in our favor. Even a tiny tweak in these conditions, and we wouldn't be here. Black holes, with their intense gravitational pull and the mysterious singularity at their centers, might be capable of disrupting the laws of physics as we know them. This disruption could, in theory, lead to the birth of a new universe with slightly altered conditions. What would happen if two supermassive black holes collided? At the heart of galaxies, you'll find supermassive black holes, each weighing millions to billions of times more than the Sun, as mentioned above. When galaxies collide, their central black holes merge in a cataclysmic event. These collisions are so intense they warp space-time, creating ripples known as gravitational waves. Albert Einstein first predicted these waves in 1916 through his theory of general relativity. The power unleashed from merging supermassive black holes could briefly surpass the combined brightness of all the stars in the observable universe. So far, the Laser Interferometer Gravitational Wave Observatory, LIGO, has detected the mergers of smaller black holes around 3 to 10 times the mass of the Sun. This discovery marked a new era in gravitational wave astronomy. However, the gravitational waves from supermassive black hole mergers are much longer in wavelength and lower in frequency, making them too subtle for LIGO to pick up. To catch these cosmic events, we'll need specialized instruments, which measure the precise pulses of neutron stars, and space-based observatories like the Laser Interferometer Space Antenna, LISA, set to launch in the next decade, are our best bets. When we finally detect the gravitational waves from a supermassive black hole merger, it will be a groundbreaking moment. Unlike the stellar mass black hole mergers detected by LIGO, these colossal collisions are expected to occur in gas-rich environments, promising a dazzling display of electromagnetic signals alongside the gravitational waves. This will be a cosmic event like no other, offering a spectacular show that could redefine our understanding of the universe. A black hole could fit in your pocket. Imagine a black hole so tiny it could fit in your pocket. Welcome to the world of primordial black holes. These miniature cosmic giants are believed to have formed from the dense clumps of matter shortly after the Big Bang. Unlike the massive black holes we often hear about, primordial black holes were incredibly small, some no larger than an atom. Most of these tiny black holes have probably evaporated over the eons. However, the larger ones might still be out there, lurking in the cosmos. Despite their potential, these primordial black holes have yet to be detected, leaving them as elusive mysteries in the vast expanse of space. They are an incredible theoretical playground. Black holes are not just cosmic mysteries, they are crucial to our understanding of the universe. They shed light on the erratic movements of stars and play a key role in deciphering the structure of our galaxy. According to Einstein's theory of general relativity, matter distorts space and time, creating the force we experience as gravity. Black holes, with their mind-boggling density, embody this theory with their immense gravitational pull. Yet these cosmic behemoths challenge the limits of our scientific understanding. At the heart of a black hole lies the singularity, a point where gravity's pull is so powerful that our current theories struggle to explain what happens. Einstein suggested that matter's information is lost once it crosses into a black hole. This clash between general relativity and quantum mechanics makes black holes a unique battleground for scientists. They offer a rare opportunity to test and refine theories ranging from general relativity to quantum physics and string theory, pushing the boundaries of what we know about the universe. That wraps up today's cosmic journey. If these mind-bending facts about black holes left you in awe, don't forget to like, subscribe, and hit the notification bell so you can keep up with all our exciting content. See you in the next video.